Hello, it's Scott Manley here. Now, if you've been following my channel for the last month or so, you'll have seen that I've been posting the occasional 360 video, these spherical videos that let you look in any direction and therefore put you in the middle of the action with the ability to control the camera. And somebody always asks me, how in God's name did you do this? Well, I'm going to actually talk about how we actually arrange these things. Now, underneath it all, YouTube is simply playing a video. If you've gone to the page without an appropriate browser or with unsupported code, then what you're going to see is the entire rectangular image for the entire sky sphere. And this is something called an equirectangular spherical projection. Now, most people are more familiar with this in the form of a world map, where you take the spherical map of the Earth and you map it onto a rectangle so you can hang it on your wall. Now, 360 videos are exactly the same concept, except of course, instead of looking outside in from the sphere, you're in the middle looking outwards, as if you're looking at, say, a sky map of the stars mapped onto a sphere. Unfortunately, as it turns out, most games don't actually provide an ability to produce an equirectangular spherical projection. Instead, they produce something which we would generally call perspective projection. This is kind of mathematically the equivalent of holding a sheet of glass up and then drawing each pixel according to what you see on the other side of it. It's so you can't actually do a sphere with a single sheet of glass. You would need a spherical version of that, obviously. But games don't do that because they're all optimized to produce flat graphics. So Space Engine was the game that I first used to create these videos, and it turns out that it has two very useful methods for learning about these graphics settings. So if you go into the settings and to display, in the projection you have two different versions, or three versions. You have perspective, fisheye, and cube map. Now I'm going to start with cube map first because that was the logical place to start, and it's a lot easier for people to grasp. So here we are, we're sitting above Saturn's rings, and you can see this is Saturn in front of me. So if I roll the camera, you can see that's rolling left and right. This is to the left of me, this is to the right of me, right? So you can see out over the rings. Looking down, you see the rings below me, and looking up, there is nothing but the plane of the galaxy. And behind me, you can see the sun and a bit of the galaxy and even a bit of the rings. And I can, if I go left and right, you can see that this one becomes like as if I'm traveling forwards, and if I go to the left, this one becomes as if I'm traveling forwards. See that? And up and down, it all makes sense. So if I go down through the rings suddenly become above me. So you can imagine how this would work. This is sitting in the middle of a box, right? You've essentially created 6 cameras, one pointing in each of the principal directions, and then you've assembled it into this screen, which you can see you could fold this around into a box, and then, using a bit of mathematics, you could transform this box into a sphere. And that may seem a little strange to you, but it's quite normal. In fact, if you played Kerbal Space Program, you may not know that the PQS, Planetary Quad Sphere system, actually treats all planets as cubes and then deforms them into spheres with terrain and everything. Bet you didn't know that, huh? Anyway, you could just in theory capture this video and then write a bit of software or download a bit of software to take each of these 6 images and wrap it into a sphere. And that's what I did initially, but there was a couple of things I had problems with. The first thing was that these white lines that are marking the boundaries, those would cause halos around them in any encoding system. The encoding system would have a little bit of color leakage, so it would be very obvious on the sphere where these things were. It was a big problem. You could actually tell you were inside a cube. The other thing, if I turn the sun over to be in front of me, look at the sun as it switches between these panes. There's a halo on this side, but none on this side. And then as I go through, you get a halo on the other side. This is quite common that a lot of graphical effects are only rendered within a certain frame, and if they're just out of frame, they won't be rendered. So this is something you have to contend with, and sometimes you had to think about how to make the scene work. Now, the way to get around the white lines was to try another projection, and we have fisheye. Now by default you have 180-degree fisheye, which is half of a sphere, but you can just run this all the way up to 360, and that will render an entire sphere into a circle. This looks totally weird and warped. I love the look of this. So let's just point ourselves at the sun. Behind us there is Saturn, so if you turn it just right, you can actually get the whole of Saturn behind us, right? So if an object is exactly behind you, it will form a complete ring. This outermost point is the point, or outermost ring is the point exactly behind you. If you actually watch the sun as I move it, you can see that there are edges here. You see that? So this is just a cube map which has been warped into this, but there are no white lines between the cubes. So this is what I ended up using. I took this and I wrote some software to turn this into the equirectangular projection. The other thing I did was I didn't render it in full screen mode. What I did was I rendered the whole thing in a window and then told the game that to render the thing in a 4K window, so I had really high resolution. That, on the other hand, meant that my frame rate was really terrible, so the whole thing was rendered and captured at about 3 frames per second. But once that was done, the video was copied over to my test system, where it was basically my Unix machine, my MacBook Pro, and it would run some code to take this and then, stretch it and warp it until it was in the equirectangular mode. And everything from there was hunky-dory and then edited together. So that's how I did it with Space Engine. And then after all that work, the developer went and added an equirectangular projection mode. So in future versions you won't need to go through any of this stuff that I had to do. Now with EVE Online, a completely different approach had to be taken. The base game didn't have support, so instead there is something called EVE Probe. Now EVE Probe is a graphics benchmarking tool for the EVE graphics engine. It plays through a number of pre-scripted scenes and it collects benchmarking data so the developers can figure out what works best on certain graphics cards. Now around February, I guess, they added the ability for people to write their own scenes. And so using this as an example, I was able to generate a bunch of scenes and start adjusting the camera so that I would take the same scene 6 times using different camera angles. And from there, it was of course simply a case of using the transformation code that I'd written to take this whole series of images and transform them into the projection that we actually need for YouTube. But that wasn't everything I did. First of all, I really wanted to deal with those edge effects, so I came up with the idea of overlapping the cameras. So instead of viewing a 90-degree field of view, I had a 105-degree field of view, and the edges would blend together and remove the hard edge effects. Now, I actually found the code, the animation code in EVE Probe to be rather simplistic, so that's why I kind of went for this whole fleet flyby idea, because it meant that everything could be pointing the same direction and moving the same direction. The hardest part was that I had to go into the EVE database and essentially pull out every single spacecraft they have, and then write a script to essentially render every scene. All of the ships in the scenes are rendered in such a way that they won't ever collide with each other. When the code is putting it in there, it makes sure that none of the spacecraft are going to be clipping through each other. On top of that, it also makes sure that the smaller ones tend to end up closer to the cameras so that we get the fast flybys and the larger ones are further away. But after that raw scene file is created, the next step was to add some appropriate window dressing, to add a planet, to add a station, a gate if possible, maybe some other wreckage, so that it would give you the idea, the environment or whatever, and that was all added manually. And in the case of stars that generated lens flare, I really wanted those to not have to worry about the edge effects that I previously mentioned, so I would always put them kind of on the border between 2 different camera views, so that you would have the lens flares guaranteed to exist on at least 2 camera views. And frequently I would actually put it up at a corner so it would hit 3, and that's why the lens flares on some of the stars are some really bizarre shapes, because the coordinate axis changes through 90 degrees for one of the panes. And that's a little weird, but it actually looks pretty good if you ask me regardless. And finally, synchronization was a big issue. Now, my code that would do the warping would also detect the difference between the black loading screen and the actual start, and most of the time that would be sufficient, but sometimes there was other things that would be weird. Weapons fire in particular. Sometimes you would have a laser that on one pane would be a different colour than on another, so you would get a laser which goes from being red to purple or something else. Or even worse, sometimes you would have a spaceship that would fly in and disappear and perhaps reappear a few seconds later. Yes, mistakes like this made it into the final cut, but you know, after all that work, I'm really happy with what I've done and I hope you have enjoyed it. I'm Scott Manley. Fly safe.